to the first question you'll see on your final exam? Can you guys all hear me? Yes? This is very similar to the first question you'll see on your final exam. It's an order of operations. It has no grouping. It has no exponents. So if we remember the rules for order of operations, this acronym called PEMDAS will help us. The first thing we look for in an order of operations question is parentheses, but it's not just parentheses, also any other grouping symbols. Parentheses, brackets, braces, those squiggly things, also absolute values. So if you see any of those kind of symbols, you should work inside those first. Since there's none of those here, we can go to the next step, which is exponents. There are also no exponents in this question. So now we're at the third step, which is multiplication and division. Multiplication and division are both on the third step. You have to remember to work them left to right. Multiplication and division have equal value. You don't always do multiplication before division. They're on the same step. You work them left to right. In this question, there is no multiplication, so we're going to do the division. Negative 18 divided by 9. You guys help me out. What's negative 18 divided by 9? Don't forget the sign. Negative 2. And then we're going to carry down everything we haven't used. So now we have 6 minus 2 minus 4, and we're down to the last step, which is addition, subtraction. There's a couple different ways you can do this. You can do this left to right if you're careful with your signs, or you can also group the ones that have the same signs together, which is what I like to do. I like to first identify where are the negatives. So I see I have a negative 2 and a negative 4. They're the same sign, so I put them together. That makes negative 6. And then I have the one positive 6 here. So we end up with 6 minus 6, which is 0. We're good? Do we have any order of operations questions? If you got 4 minus 4, it still came out to be 0. Yes, if you did them left to right, it will be 4 minus 4, which just proves to you that you can do it either way and still get the same answer. If you start up here and you do 6 minus 2 minus 4 and you work it left to right, 6 minus 2 is 4. 4 minus 4 is 0. You have the same answer. You can work it either way and you'll get the same answer. If it's not too bad here if you only have 3 numbers that you're trying to add and subtract, but when you have a string of 8, 9, 10 numbers, it's easiest to clump the negatives together and clump the positives together. So I have another question here. Yay. Let me write this out. I have, and I'm not really sure where this is coming from, so I have 10 minus 5 brackets, negative 3. Okay, this is coming from the practice final in Blackboard. Okay. All right, this is obviously an order of operations question. So we're going to put our PEMDAS up here again so we can check these off as we go. The first step is parentheses grouping symbols. I have 2 sets of grouping symbols here. I have the brackets and the parentheses. Which one should I work in first? Go as far in as you can. Very good. Go as far in as you can. And since the parentheses are inside the brackets, I'm going to start in here first. But inside this parentheses, there's also 2 operations. There's a negative and there's an exponent. So which one of those should I do first? Exponents always come before addition and subtraction. So we're going to work on this exponent first. So this is actually a kind of a tricky question right off the bat because the exponent is on the 7, but it's not on the negative. So this is going to be 7 times 7, which is 49, and then this negative comes down like this. Okay, so this is a little bit tricky. If your negative is not held in with parentheses, it's not part of the base for that exponent, unless it's held in. If it's in parentheses like this, and the exponent is out here, then this means negative 7 times negative 7. So you see the difference right off the bat. So what do we have here? Now we're going to do the subtraction. 5 minus 49 is what, guys? Negative 44. And then I'm replacing everything I haven't used from all of that up there. I'm really sorry. I'm still trying to get the hang of this pen here. I haven't used it for a while, so I'm sorry my writing's a little bit sloppy here. All right, now we've done everything in the parentheses. So now we're working inside these brackets here. Inside the brackets we have a multiplication here and a subtraction here. So which one should we do first? Multiplication comes before subtraction, so I have -2 times -44 makes positive 88. So I end up with -3 plus 88, which is, anybody? 85. Okay, so I still have a 5 out here and a -5 over here. So we have all the grouping symbols done now. Inside the grouping symbols we did any exponents. Now we're at multiplication and division. And there's only one multiplication here, the -5 times the 85. How do I know this is multiplication? Because there's a brackets here with a number right next to it and no symbol in between them. When there's no symbol in between, we know this is multiplication. So -5 times 85 is -425. You guys check my work there? Okay. So we have 10 minus 425 minus 5. So again, I'm going to group the negatives together kind of like I did on the last one. See, I see these are both negatives. I have -425 and -5 makes -430. This is a positive 10 and a -430. Since they're different signs, you subtract. You get 420, and it's a negative because the negative was bigger. That was a great question. Wow. That's a long one. That's a long one, but it was a good question.
Before you move on.
It's possible. It's possible. What did you say, Hector?
So before you move on, somebody had a question about the -7 squared.
Okay.
Can you differentiate between when it's a base, when it's not a base? I know you did it up there, but can you show the two?
Okay, I'm just going to kind of draw a little.
You actually do it.
Okay. When you have a number with a negative sign in front of it and an exponent out here, the negative sign is only part of that base if it's being held in with parentheses. In this particular expression that I just wrote here, the negative is not part of the base because the exponent is only on the 2. So the negative just drops down, and we would just have 2 being cubed here. There's only one negative because that negative is not held in. The exponent is only on the 2. So this turns out to be -8. But in the case where we have a -2 in parentheses with a cube on it, or a square, let's do a square instead this time. Because this is held in with parentheses, the exponent is on the parentheses. So everything in the parentheses is the base for that exponent. Yes? Okay, so in the room, somebody's saying that because we're multiplying 7 times 7 and the result is actually a positive 49, that she wants to put a positive here in front of the 49. To remember what you're doing here, just remember this negative is not attached to that 7. That negative is not disappearing somewhere, and you can see I drew an arrow to indicate that that negative is not going anywhere. I'm going to change my pen color here so you guys can see what I'm talking about. Maybe. Do you think I can change my pen color? Okay. This negative right here is not disappearing. It's not part of the base. So pull it down before you even think about doing this with the base. If you take care of the sign first, then you might not miss it. It's not going to disappear. And yes, you're right. This did come out to be positive 49. And if this negative was a positive here, we would have had positive 49, but don't lose it. If you pull it down first, you might not forget to do it. Okay, over here on the base, -2 times -2 makes a positive 4. All right, do we have any other order of operations questions? No? Maybe we can move on. Do we need to do another order of operations? Do we have a poll or not? No? Okay. Let's see. Let's do this order of operations. Whoa, my pen is... All right, guys, in the room and online, somebody tell me where I should start with this order of operations question. Parentheses. We always start with grouping symbols. So there is an operation in these parentheses. 14 minus 6 is what? 14 minus 6 is 8. So we have an 8 here. Then I'm replacing everything I haven't used. All right, after parentheses, then I look for what? Exponents. I have an exponent up here, right here. What's the base for this exponent? What's the base? The base is what the number that the exponent is on, and that would be the 8. The base is 8. The exponent is 2. This is a positive 8 times a positive 8 gives us what? 64, but don't forget to carry down what? That negative sign. Good. That's why I'm pointing it out to you guys. You have to carry down that negative sign because it's not part of the base and it didn't disappear when you did that multiplication. So, all right, we did all the exponents. Now we're going to do multiplication and division, left to right. So which one's first? Right, multiplication does not come before division. They are on the same level. You have to work them left to right. I will tell you guys, I'm going to give you a little clue. This question is testing whether you remember that. They will always have a division before the multiplication in this question. So don't forget, division, multiplication, left to right. So I have negative 64 divided by 8 is negative 8 times 6. I still have this 23 here. Now what? Negative 8 times 6. So I'm still doing multiplication and division. I just did the division first. Now I'm doing multiplication. This makes negative 48. I have 23 minus 48, which is this going to be positive or negative? Negative. Yeah, when they're different signs, you subtract. You take the sign of the larger one, so this comes out to be negative 25. So we got all of this. Good. Good job. Absolute value? Absolute value symbols. The absolute value symbols are here to here, these straight bars. Does anybody remember what absolute value means? The absolute value does always come out to be positive. So when you're working with absolute value, after you take the absolute value of a number, it will be positive. So they always come out to be positive. It means how far is this number from 0? That's what it means. How far is this number from 0? But you have to be careful. In the absolute values are also part of grouping symbols. Okay, remember when I said parentheses, brackets, remember this? I did this on the first slide. Absolute values are also part of grouping symbols, so you work inside them first. You cannot take the absolute value of these two numbers individually. I mean, you can, but you shouldn't. You can't take the absolute value individually. You work the operations inside them first, and then you take the absolute value of one number that comes out of these bars. So this is what we're going to do first.
Wait, before you go on. So you said that the absolute value is the distance from 0. Does that mean it's the opposite of whatever is inside?
Not necessarily the opposite. It's a unit measurement that always comes out to be positive. How far is this number from 0 in units? So when I work this, 8 minus 14, I get negative 6. Okay? How far is negative 6 from 0? It's 6 units from 0. It's always going to come out to be positive. Even if I have a positive number already in here, how far is positive 7 from 0? It still comes out to be positive. So no matter what number you have in there, you're right. It always comes out to be positive. Whether it's a positive number inside or a negative number, the absolute value does come out to be positive. So we end up with 6 plus 9 here after we take the absolute value, which is 15. Do we have any absolute value questions? Or can I go on to the next topic? If both of the numbers inside are negative, I'm just going to draw a little box here, guys. If we have a negative 2 minus a 3, like this, you still have an operation inside those absolute value bars. You still have to do the operation before you take the absolute value. You are only going to take the absolute value of one number. The operations will all be done already. So you have to do this operation, which is a subtraction, before you take absolute value. Negative 2 minus 3 is negative 5. The absolute value of negative 5 is 5. So it doesn't matter how many numbers you have inside and whether they're positive or negative. You're going to do all the operations first. Take the absolute value of one number at the end of all the operations, and then the absolute value bars disappear. Are we good? We're going to go, yeah, I'm going to go on to 4 if we don't have any other absolute values. Okay. Okay. Okay, let me see. Are you guys okay if I erase this? Well, okay, the question is, what about if we do the same exact question with a negative number on the outside? So I'm trying to erase just my writing. How do I erase just my writing? E. Oh, there we go. And I'm going to put a -2 out here. All right. Again, thinking about PEMDAS. Parentheses. Oh, no number. Okay, just a negative sign. Okay, so you're still going to work inside the grouping symbols first. You still have to work, so you're going to ignore that negative sign for now. It's there. 8 plus -14 is still -6. We still have, you know what, I think I can drop this +9 because that doesn't really apply to what she's asking me, right? So I'm going to drop the +9. All right, you're still going to take the absolute value of -6. This negative, what do you guys think is going to happen with this negative sign? It's going to bring it down. I think the question here is, should we cancel these negative signs? Is that the question, maybe? These negative signs will not cancel across absolute value bars. That's an addition and subtraction function. You will not cancel before you take absolute value. You have to take absolute value first. The one in front will drop down. The absolute value of -6 is still +6. How far is this from 0? It's still 6. But it turns out that the answer to the entire question is -6 because of that extra negative on the outside. That was a really good question. Thanks for asking, whoever asked that question. Will Maris, that was a good question. Okay, are there any other questions about absolute value? Okay, let's see what we got up here. Somebody asked for question 4, right? Okay. The directions for this question are simplify, right? What does simplify mean to you guys? Group stuff together that might be the same kind of stuff. We call that combining like terms. Anything else? Simplify means to get it as small as we can, reduce some things. All of that is part of simplifying. So this looks pretty complicated now. In the process of simplifying, we get rid of all the grouping symbols. We combine everything that can be combined, all like terms. We reduce all fractions. That's all part of simplifying. So again, you go as far in as you can. You look at the inside grouping symbols or parentheses here. If there's anything in these parentheses that can simplify, we do that first. I have an x plus 5, which are not like terms. They will not combine. Sometimes there are like terms, and you should simplify them before you get rid of the parentheses. It just makes your work a little bit easier. So since I can't do anything inside these parentheses, the only way for me to get rid of these parentheses is to distribute. Good. So I'm going to distribute this 6, which is multiplication. Now, make sure you're only distributing the 6 to the parentheses that's right next to it. It will not distribute to this x over here. This x is being added on after. So I still have a -6 out here. 6 times x is 6x. 6 times 5 is plus 30. Then I have a plus x. Then I have brackets. All right. Now again, I'm looking inside the brackets since the parentheses are gone. Is there anything inside the brackets that I can simplify? Yeah, good. I have like terms in here. I have a 6x. And how many x's is this? What's the coefficient on this x? 1. So when you combine the 6x and the 1x, what do you get? 7x plus 30. Now everything's simplified inside the brackets. So now the only way I can get rid of the brackets is to distribute this -6. Good. Be careful when you have a negative on the outside because you're distributing that negative with the 6. So you're multiplying. Negative times positive makes what? Negative. 6 times 7 is 42, and you have the x there hanging on. Then you have negative times positive again makes negative. 6 times 30 is 180. After you distribute, you should always look for like terms. Are there any like terms? No, there are no like terms. What makes like terms, you guys? Why aren't these like terms? All right, the like terms are determined by the variable. Since this term has an x and this one doesn't have any x, they're not like terms, so we can't add them together. So this is the final answer here. Do we have any other simplify questions? No? How about evaluate? Let's evaluate. What does it mean to evaluate? What do the directions mean? Evaluate the expression when w equals -4. Okay, in the room they're telling me that where the w is, I have to put a -4. Is that right? You have to substitute a -4 where the w is. You're absolutely right. I think the easiest way to do this is just my opinion, so if your teacher taught you a different way, that's okay, is to start with parentheses every place you see the variable. Okay? And then put the value for the variable in those parentheses. And then go back and replace all these other symbols. So I have a -6 here, I have a square here, I have a plus, a 5, a plus, and a 3. If you do this with the parentheses, you won't lose any multiplication. Your multiplication won't accidentally turn into addition. And also, there's a concern here with this negative on this exponent. You need the parentheses to hold that negative in. I think this is the easiest way. If you have another way that you're doing this that's working for you, you don't have to change your way, but this is the way I teach it in my class. So once you get that -4 substituted in instead of the w, then you're just following order of operations to simplify this. So are there any grouping symbols? Are there any grouping symbols? There is 2 sets of parentheses, but there's no operations in those parentheses. Are there any exponents? Yes, we have this exponent here. What's the base for this exponent? -4. That means -4 times -4, which is +16. Negative times negative. You still have this -6 out here, and now I'm carrying everything else down that I haven't used up yet. Everybody still with me? Okay, so exponents are done. What's the next step? Multiplication, division, left to right. Do we have any multiplication or division? Yes, we have 2. Okay, we have a multiplication here and here. So -6 times 16 is negative times positive makes negative. So we have -96. Then we have 5 times -4 makes -20. Then we have +3. All right, good. That's multiplication, division. So add and subtract. All right, where are the negative terms? These are both negative. They're going to clump together, aren't they? Because they're same sign. That makes negative what? That makes -116. Then you have the +3. These are different signs. So we have to subtract them. And we take the negative since the 116 was bigger. Good. That's evaluate. Everybody remembers evaluate. Good. So let's see what's next. Solve. The directions here say solve, but there's also one big clue on this question that's telling you that you're solving that's different from the other questions we did. We're solving for r. How do you know that this question is a solve besides the fact that the directions say so? It has the equal sign. Good. This is an equation. All the other questions we did before were expressions. Expressions just simplify. The directions will say simplify. This one says solve. At the bottom it should say r equals something, whatever r is. It could be a fraction, could be a whole number, could be positive, could be negative. At the bottom it should say r equals something. So here we go. How do we solve? What's the first step to solving? Distributing is part of simplify. So when you're solving, you're going to simplify both sides first. So we're going to use everything we did before, and now we're just going to take it a step further. So we have to simplify each side. We're going to simplify this side, and we're going to simplify this side. And you're right. We're going to distribute because there's nothing else that we can simplify in those parentheses. So be careful. Right off the bat, I see something that's going to cause some problems. Do you guys see it? What is it? All those negative signs. All those negative signs there's all those different places for you to make mistakes. We'll see all those going on our head. saying be careful with these. This is where students make a lot of mistakes, so be careful. I have a negative times a negative makes what? Positive. 2 times 9, 18 with the r on it. Good. And again, I have negative times negative makes positive. 2 times 6 is 12. Equals, on this side. These are positives. 6 times r. This is positive times positive plus 30. All right. So are both sides simplified? Yes. We don't have anything else that we can simplify on either side. So once both sides are simplified when you're solving the equation, then you want to get the variables all to one side. And it doesn't matter which side you put them on. It really doesn't. As long as you're careful with your signs, you'll get the right answer either way. So I'm going to take this 6r off the right, and I want it to be on the left with the 18r. So I need to use the opposite operation. Right now it's plus, positive. So I'm going to subtract it. Both sides. Same thing on both sides. So over here, positive 6 and a negative 6r will cancel, and I just have 30 left on the right. Over here, I'm going to combine like terms. 18r minus 6r is what? 12. Good. And have 12. Once your r's are all on one side, then all your constants or your number parts need to be on the other side. So I have to get this 12 off of this side, since this is where I put the r. How do I get this 12 off? Subtract. Right now it's a plus, so I'm going to subtract 12. This is the opposite operation. Same thing on both sides. Positive 12 and negative 12 cancel and make 0, so we have 12r only on this side. On this side we have 30 minus 12, which is 18. Good. What's the last step? How do you separate this r from this 12? Yeah, this is multiplication, so to separate it you divide. So you divide the coefficient, 12, off. Do you see why this works, you guys? 12 divided by 12 makes 1, and that's what we want. We want 1r, so we have 1r here. 18 divided by 12 is a great answer, but there's something wrong there. It's not simplified. We always need to simplify fractions. Fraction answers will, and you know what? I will tell you guys this. You will not see this as one of your answer choices. This is the right answer, it's just not finished. It's not simplified. All fraction answers need to be simplified. So how do we simplify 18 over 12? Divide by the greatest common factor, which is 6. So we have 3 over 2. R equals 3 over 2. Are there any questions about that? It's possible that you could see this as 1 1/2. I'm not going to say no. It's possible. But most of the time in algebra we leave our fractions as improper. Most of the time. I can't, to be honest with you, I can't remember the specifics. So I'm going to say it's possible either way. But you guys know how to convert this from improper to mixed. Do we need to review how to convert from improper to mixed? Okay. Could be either way, but you will never see both. You would never see both answers because they're both the correct answer. And that would not be fair. They're both the correct answer. There will only be one choice. It will either be 3/2 or 1 1/2. Does that answer everybody's question, Hector? All right. Are there any other solves? Oh, I have solves in front of me here. I have solves in front of me. Here we go. Let's try this. Here's a new one. 5 times. Can everybody still hear me online? I'm doing a sound check here. If you can still hear me online, please raise your hand. We're doing a sound check. We just want to make sure everybody can still hear us. Okay. Okay. So there's just a little bit of lag. I'm sorry. There might be a little bit of lag. Everybody in the room can still hear me? Okay, great. No lag here. Okay. All right, this is another equation for us. I didn't write the directions, but you guys know what the directions should be, right? What are the directions for equations? Solve for q. Good. That means get q by itself, find out what q equals, what value for q will make this a true statement. The first step is to simplify both sides. So where am I going? What am I doing first? What do we call that, you guys, when I multiply that 5? We call that distributing. Good. So 5 times 2q is 10q. 5 times 5 is 25. Over here, is there anything to simplify on the right? It's already simple. There's no like terms. It's already simple. So what's next? Once I have both sides simplified, what do I do next? Okay, I have to get all the variable on the same side. So they're like terms. I need to either move the 10q to the right with the 4q or move the 4q to the left with the 10q. You'll get the same answer both ways. Most of the students like to put the variable on the left, so I'm just going to subtract this 4q and combine it with the 10q over here. That seems to be the way most students are going. So these will cancel and I have a -3. Don't lose that negative. That negative belongs with that 3. Don't lose it. You'll end up with a wrong answer at the end. 10q minus 4q is 6q plus 25. All right, once all the q's are on one side, I have to put the numbers on the other side, so I have to get this 25 off of here. Using an opposite operation, I'm subtracting 25 from both sides. I have 6q equals -3 minus 25, same signs. So what are we going to get? -28. Same signs. Add, keep the same sign. Last step, separate this 6 from this q by using division. All right, so q equals, again, my fraction is a negative divided by positive, so the fraction itself is negative, and you'll probably see the negative out front, not on the top, although they do mean the same thing. But most of the time, the answer choices will be written with the negative out front. Okay, just to let you guys know that. I don't want you to be confused. It does mean the same thing, so don't be confused by it. But again, this fraction needs to be what? Simplified or reduced. So what's the common factor for 28 and 6? 2. When I divide these both by 2, I get -14 over 3. Very good. And I'm going to leave that improper just because I kind of have a hunch that we're leaving fractions improper. Old school. Okay. New school doesn't matter. Let's do one more. I have a different one here. Did everybody get all this before I erase it? Well, here we go. I have a different equation here for us to solve. I'm a little confused, though, about this letter. I'm not sure if this is a number or a letter here. Is this a 9? Okay, thank you. All right. We're going to solve for the variable is z. Solve for z. All right. This one looks like a lot of fun. Anybody else think that? Do you guys think this looks like fun? I think this looks like fun. Yeah? Fractions are your friends. Fractions are your friends. No, you don't think so? All right. I know a lot of students think fractions aren't their friends. How great this would be if there were no fractions in here? Would you guys? Yeah, we would like to solve this with no fractions. So, okay, in the room, they're telling me to find the lowest common denominator. Professor? What? Online, they're saying no. Nobody wants to solve this with fractions in it. So we're going to clear the fractions by using what would be the lowest common denominator. So I'm going to look at these denominators. Let me see if I can. Let's change our ink colors again. Looking at these denominators, the least common multiple, which is the same as the lowest common denominator, would be 9. We're not going to change these to 9s, though. We're going to use the 9 to get rid of them. So I'm going to multiply the entire equation, every term, by 9. And I'm going to write this as 9 over 1. So you guys know 9 and 9 over 1 are both the same as they're 9. What's going to happen here is I'm going to distribute this 9. Okay, so I have 9 over 1 times the first term is -8/9 z. Okay, then I'm going to do 9 over 1 times 5. I don't really need 9 over 1, so I'm just going to use 9 times 5. Then again, distributing still, 9 over 1 times 1/3 z. and then still distributing to this very last term, I'm going to use the regular 9 again since it's a whole number. Okay, I was really careful with my signs here to make sure that I had this plus sign coming in here and this minus sign coming in here. All right, but all I'm doing here is distributing a 9, multiplying 9 times every term, because we're going to have some magic happen next when you do this. I like magic when I work math. All right, I'm going to look at this first term. When we multiply fractions, before we multiply, we can cross-cancel or reduce. Does everybody remember reducing before multiplying? Do you see these 9s can reduce? Yes, they're both divisible by 9. When I divide them each by 9, they turn into 1s. Okay, no reducing with the whole numbers, but I can reduce this one too before I multiply it. So I'm going to reduce, and then I'm going to go through and multiply every term. This 9 will reduce with this 3. They're both divisible by what? 3. When I divide this by 3, I get 1. When I divide this by 3, I get 3. Now, of course, there's no reducing with the whole numbers because they're whole numbers, not fractions. But you know you did the right thing, because if you look at the bottoms, what happened to the bottoms of these fractions? They turn into 1, which means they're not fractions anymore, are they? They're going to be whole numbers now when I multiply them, and that's the next step, to go ahead and multiply after you reduce. So you have 1 times negative 8z here. Everybody see that in the first term? 1 times negative 8 makes negative 8, and the variable z is still there. The bottoms are 1, so I don't need the bottom anymore, do I? I have 9 times 5 in the next term, gives me 45. In this fraction term here, I have 3 times 1 times z, which is 3z. And in the last term, I have negative 9 times 6, giving me negative 54. This is called clearing the fractions. It makes the equation a lot easier to solve if you clear those fractions out as a first. You see how much easier this is now? This is great. We love this equation, don't we? If you can master this skill, you're set for next semester in intermediate. You'll be great, because they're going to throw those fractions in there. So you've got to be able to deal with them. All right, we're going to continue to solve this equation. Both sides are simplified already, so I need to get the variable on the same side. This time I'm going to add 8z and put the variable on the right. Anybody know why? Good. That gets rid of the negative for me, doesn't it? And it doesn't matter. You'll get the same answer. If you guys already worked it by putting the variable on the left, you could just keep your work, because you should have the same answer as me at the end. So now I have 45 equals 8 plus 3 is 11. I have 11z minus 54. So since I'm solving for z, I have z all over here on the right. I need to get this 54 off of here. What should I do? I'm going to add the 54 to both sides using the opposite operation. So these are canceled now. I have 11z equals 99. How nice for us. Anybody know why I'm saying how nice? Yeah. When I divide by this 11, I'm going to get z equals 99 divided by 11 is 9. So z equals 9 here. Great job. And how do we check our work? You take this 9, you put it back in where z is in the original equation, and you use order of operations to simplify. And both sides should equal the same number, shouldn't they? That's how you check an equation. I'm not moving on yet. I'm just moving my paper. Yes? Many questions.
Can you talk about the difference between a lowest common denominator and a greatest common factor? Why isn't it 3 here?
Okay, all the way at the top when we chose the 9 to clear the fractions, I said the least common multiple or the least common denominator. Turns out that whatever is the least common multiple is also the least common denominator. So sometimes those terms are used interchangeably. But the least common multiple, I'm wondering if I can erase all this work for a whiteboard to kind of explain this, or do I need this work still here? Can I erase? No? He's telling me no. Okay. 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 I have least common multiple and greatest common factor. Okay, actually we use these acronyms a lot. The difference between a least common multiple, if I'm using the numbers 9 and 3, is this is the smallest smallest number that is a multiple of 9 and 3. So what are multiples? The multiples are the numbers that you get when you multiply a number. So the multiples of 3 are the numbers you get: 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, and so on. Those are the multiples of 3. The multiples of 9 are the same thing except when you multiply 9. 9 times 1, 9 times 2, 9 times 3, 9 times 4, 9 times 5, and so on. So the least common multiple is the smallest number that you see in both of those multiple lists, and it is 9. It's the smallest number that's divisible by 3 and 9. That's what the least common multiple is. The greatest common factor, on the other hand, is the largest. That's what greatest means. Largest number that is a factor of 3 and 9. So what are factors? Factors are numbers that you can multiply to get 3 or 9. The factors of 3 are only 1 and 3, because those are the only two numbers you can multiply to get 3. The factors of 9 are 1, 3, and 9. Those are the numbers you can multiply to get 9. So the greatest common factor is the largest number that's in both of those lists. So the greatest common factor is 3. The greatest common factor is a number that goes into 3 and 9. So I don't know. Did that help? Yes, another question.
Can you work the same problem without clearing the fractions?
Absolutely. You're never required to clear the fractions on a fraction question. It's not a requirement. The only reason we do it is to make the equation easier to solve. If you keep the fractions in, you end up having to get common denominators and using reciprocals at the end, which is not unmanageable if you're good with fractions. Anybody that's good with fractions can solve an equation. I don't have this. No. I don't want to do it without, let me see if I can write this down. 8/9. I really would prefer not to do this because it is harder, which is the whole reason why we teach clearing fractions. And I will show you a few steps to show you that clearing the fractions might make it easier.
This one, can you talk about when it's appropriate?
Yes, when it's appropriate to multiply by the reciprocal or not. If you have more than one fraction in your equation, as a general rule, you don't start with a reciprocal. The reciprocal is used at the end when you have one fraction term and you just need to get rid of the fraction coefficient. In this equation, if I didn't clear out these fractions, the first step would be to get these z's both on the same side. So I would add 8/9 z to get it off of here. So I would have to add 8/9 z. Does everybody see what the problem is right off the bat? In the room, what's the problem here? These will cancel, and I have 5. But here, to add these fractions, I have to do what? You have to change the denominators. I'm not saying it's impossible, and the 3 and the 9 are easy to work with. But what if you have a 5 and a 7, or a 7 and a 12? They're a little bit harder to work with that way, so you would have to get a common denominator before you could add these. So it's possible, and you could do this. If I get a common denominator here, that makes 3/9 z added to 8/9 gives me 11/9 z, and I still have a -6 here. Okay, since my z is on the right, I have to add 6 to get it off. So I have 11/9 z equals 11. All right, now what? Now I have to take care of this fraction because I have to separate it from the variable. When you have this situation where I am right here at this point, a fraction coefficient, one number on the other side, this is where you would use the reciprocal. Use the reciprocal of whatever the coefficient is. The reciprocal of 11/9 is what? Anybody know? What's the reciprocal of 11/9? 9 over 11. So if I multiply this times 9 over 11, these 9's cancel, these 11's cancel, and I have just z. But remember, you have to do the same thing on both sides. Okay, so this 11 is going to have to go over 1. These 11s will cancel, and I get 9, which I think is the same answer I got when I did clear the fractions. If you're great with fractions and you don't mind getting common denominators, it's absolutely possible to solve this, but it's also, to me, it's more steps. It's more steps. Either way, you get the same answer as long as you're careful with those fractions. You'll get the same answer. I think that's all to solve, so maybe we'll look at something else. This is the same thing I just did. I just did a question just like this. Real quick, let's do this one. What are you supposed to do first? You're solving for y. We're going to add 6 to both sides. And what do we get? We get 6/5 y equals 0. Okay, is that 0 throwing you guys off? 0 is a valid number. 0 can even be a solution to an equation. Don't be thrown off because it comes out to be 0. 0 is a number. It's on the number line even, isn't it? So, but you're not done solving here, are you? No. You still have to get y by itself. So what are you doing? Divide by. Dividing by 6/5 is the same as multiplying times the reciprocal. So you're going to multiply times the reciprocal, which makes these cancel, but you have to do the same thing on this side. Just turns out that when you multiply the reciprocal times 0, it still equals 0. 0 is a valid answer. Just because you get 0 does not mean you're wrong. It is a valid answer. It's on the number line. Are we good? Okay. Let's look at this one. This is a solve, but it's got a little twist to it. It says solve for t, but t is not the only variable in this equation. So am I going to be able to solve this down so it says t equals 3? No. Those other variables are not going to go away. They're still going to be there. The idea here is that you just use opposite operations to rearrange this equation so that t is isolated by itself on one side of the equation. But the other variables are still going to be there, just on the other side. Okay? So when you're solving for a variable like this, you go as far away as you can. That would be over here. Get rid of this term first. If this is a negative 8z, we get rid of it by adding 8z. Do the same thing on both sides. So these will cancel. I have 7t. But the trick is over here on the right, on the left, these two terms are not like terms, are they? So we can't put them together into the same term. So we're just going to kind of list this as x plus 8z because they're not like terms. This is 7t. We haven't solved for t yet. We got to separate the t from the 7. So you have to divide by 7. The easy way to do this is to put just a big fraction bar under this whole side and put a 7 under here, because you would have to divide the whole side by 7. I'll tell you guys, this is a perfectly acceptable answer when you're working a fill-in test. There's nothing wrong with this answer. It's a good answer. I like this answer. But when you're choosing multiple choice answers, this may not be the form that you see. So we're going to transfer this into two terms. Okay, the t is by itself now on the right. Everybody gets that, right? So what's the coefficient here in front of x? 1. So we're going to make a fraction out of this with the 1 on the top and the 7 on the bottom. And we're going to kick the variable over to the side. This is the same as 1/7 x. Bring the plus sign down. Same thing here. The top and then the bottom. And make this a fraction, the 8 over the 7. Kick the variable to the side. We got it? These are the same answer. I don't want you guys to think this was a bad answer. What do we have here? We had x plus 8z over 7. This is a good answer. I like this answer. When I give fill-in tests, I give full credit for this answer. These answers are equal. They're equivalent. It's just the way that your test is written, most of the time the answers are written in this form. So you need to be able to distinguish them. Equivalent answers. This one? Yes. Yes, there are some. You never see this answer? You have to transfer it to two terms like this. I will tell you on your final exam you could see either form of this answer. So just be able to transfer from this answer to this answer and you'll be good. Where the fractions were coming from. Just so the students in the room are just telling me they never understood where the fractions were coming from. So, okay, we're good with literal equations. We don't have any other questions for literal equations? Okay. Let's do question 9. Translate, or do we need to move to a different topic? Do we have any other questions? Ready? Yeah, I'm going to. Okay. This one's more complicated, probably more applicable here. The length of a rectangle is 2 feet more than the width. The perimeter of the rectangle is 72 feet. Find the length. Okay, this is one of the 6 possible kinds of questions you could get on your final exam. So we're dealing with a rectangle here. So I'm going to draw a rectangle. Sorry, it's a little bit jiggly there. We have length and we have width. What information do we have? The length of a rectangle is 2 feet more than the width. So I don't really know anything about width. So we're just going to leave width here alone, but I do know some stuff about length, so I'm going to write a little equation for length. It says the length, I'm Xing this out, it's a prepositional phrase, you can get rid of it, but that's going real grammar on you, okay. The length is, the length is, I'm just 2 feet more, means 2 plus, than the width, 2 plus W. The length is 2 feet more than the width. So the key words there were is and more. The perimeter is, again, is means equals 72. Find the length. Okay, there's one really important piece of information that they're not going to give you for this question that you have to have it in your little brain there. What is it? The formula. The formula for perimeter of a rectangle is, what's the formula, you guys? Perimeter of a rectangle, 2L plus 2W, 2 times the length plus 2 times the width. It also works as length plus width plus width. They're the same thing, aren't they? This is just the simplified version of this, isn't it? So either one of those will work. Either one will work. All right, so we know the perimeter is 72, so I'm going to replace P with 72. I know the length is 2 plus W, so I'm going to replace L with this little equation I made that says 2 plus W. So I have a 2 times 2 plus W. I just substituted length with this little equation I made for length to get it out of the big formula. The idea is that you can't solve this with all the variables in. You have to get rid of some of them. You need to get rid of all but one. And since I don't know anything about width, the width is the one I have to leave in. So I got rid of the perimeter because I know perimeter is 72, the P. I got rid of the L because I know L is equal to 2 plus W. So I got rid of the L and I replaced it with 2 plus W. I have to leave the W in. I don't know anything about W. So now we're just going to simplify and solve. Where are we going to start? Distribute. So we have 72 equals 4 plus 2W plus 2W. After you distribute, combine like terms. You have a 2W and another 2W, so you have 4 plus 2W plus 2W is 4W. 4 plus 4W. Now what? You're going to subtract. You need to get the W by itself, so we're going to subtract the 4. Subtract 4 from both sides, and we end up with, what's 72 minus 4? 68 equals 4W. You guys all still with me out there? Okay, I just want to make sure I'm not talking to myself. What's the last step? Divide by 4. So we get, is 68 even divisible by 4? Yes? How many times is 4 going to 68? 17? W equals 17? But does that answer the question? What's the question? Find the length. Okay, we solved for width. Does that mean we did it all wrong? No, no. Now you're just going to use what you know about width right here in this little equation to find length. Length equals 2 plus width. Well, since width is 17, length equals 2 plus 17, so length equals 19. And what are the units? What are the feet? Feet. Watch out for those units, because you don't want it. Yeah, you don't want square feet, do you? You want regular linear feet when you're looking for length and width. Regular linear feet. Are we good? How about a proportion? Are we up for a proportion? Okay, people in the room are telling me they had some problems with this, so we're going to do a proportion. Identify the proportion listed below that solves this problem. A car can travel 500 miles on 5 gallons of gasoline. How far can the car travel on 32 gallons of gasoline? I will tell you guys that what I tell my class is when you're working with proportions, proportions are all about comparisons. You're comparing two different things here. And it's about the units. What kind of things are you comparing? You're comparing miles and gallons. If you use those units when you're writing your proportion, you won't be confused about where the numbers go. So that's how I'm going to use. I'm going to write the fraction bars, and I'm going to put miles over gallons on both sides, just like this. That way I won't be confused about which numbers go where. Now, there are 4 correct ways to write this proportion. So if you've been writing it with miles over miles, this is not wrong. This would be okay. Okay, I just think it's a little bit easier to understand the first way I wrote it. So the first part of the story says 500 miles on 5 gallons. So 500 miles on 5 gallons. The second part of the story says how far on 32 gallons. So where does the 32 go? And what should be up here? This is what I'm looking for. How many miles? Now, I'm going to, I know I have a little eraser here somewhere. Do I have an eraser? Okay. All right. Do you see this exact equation? Do you see this proportion? 500 over 5 equals x over 32. This says 500, 5 over 500. This is not the same. 500 over 5, but guess what? This is not the same on D. Can't be A or D. I don't see this proportion. Do you guys see this proportion? But like I said, there are 4 correct ways to write this proportion. So if you look for your variable and whatever's diagonal, on all correct proportions, the 5 will be diagonal from the variable. Okay, so it's B because it has the 5 diagonal from the variable. The reason for that is because if I was going to solve this equation, I would this proportion, I would write an equation, wouldn't I? And you would cross multiply. The equation to solve this proportion says 5 times x equals 500 times 32. So if you don't see your proportion, you have to look at the other ones and see which one will give you the same equation. This one here, letter C, says 5 times 500 equals 32 times x. That's not the same equation, is it? B says 5 times x equals 32 times 500, and this is the same equation. So if you don't see your exact proportion, you have to look for the one that gives you the same equation. Are there any questions about proportions? No questions about proportions? Okay. Exponents are next. Are we up for exponents? Yes? What do you guys think we should do first? Okay, since there's parentheses, it's always a good idea to look inside them to see if anything can be simplified, right off the bat. Okay? Sometimes there is stuff in here that could be simplified. On this question, there isn't. But it's always a good idea to check. It will make your life easier if you simplify in parentheses first before you start doing anything with these exponents. Okay? So always check to see if anything can be simplified. Then the next thing I notice is this 3 hanging out here. Yeah, what does that mean? That means that this whole entire parentheses is raised to the 3rd power. The base is a squared b to the 4th. And it just means that you have 3 of them, right, being multiplied together. Now, there is a shortcut for this, but I'm writing them out so that you guys can see what's happening, right? Yeah, does anybody know what the shortcut is instead of writing them all out? Yeah, if you have exponents raised to exponents like this, you can multiply the exponents. So we'll have a 2 times 3 is 6 to the 6th power, b to what power? To the 12th. You can see that's exactly what happens when you write them out, can't you? You have 2, 4, 6 a's and 4, 8, 12 b's. It's the exact same thing. It's just, this is the shortcut to multiply them instead of writing them out. This second parentheses doesn't have any exponents on it, so you can just drop them. We have a cubed b to the 4th. Now we need to put the a's together. This is multiplication. So what's the shortcut? When you multiply the same base, what do you do with these exponents? You add them. So we have a to the 9 and b to the 16. 16. 12 plus 4 is 16. 12 plus 4 is 16. Are there any questions about that one? The exponent questions get a little bit harder as we go on. So if you guys have any exponent questions, you can write them down. All right, what's the first thing you guys notice on this one? There's a division. Good. It's a fraction with a division, and you have negative exponents up here. We don't like those negative exponents. In some higher level math courses, it's fine to leave them negative, but in this course, we practice making them positive. Okay? So that's the first thing I'm going to ask you. How do you make negative exponents into positive ones? You can, yeah, basically, they could be on the top or the bottom. That's a good question. Are they going to cancel? Will this a to the negative 5 cancel with this a to the 5? What do you guys think? When you have a fraction, the basic rule for fractions is if you have the same thing on the top and the bottom, they reduce to make 1, don't they? But these are not the same thing. At 5 and negative 5 are not the same thing, so they don't cancel to make 1. But that was a really good question. Good. So we want to make these positive. You make exponents positive by moving them into their reciprocal. That means if they're on the top, they'll be positive on the bottom. If they're on the bottom, they'll be positive on the top. So these need to move. But what about the ones that are already positive? Yeah, they don't need to move. So I'm going to move a to the negative 5 down, and it's going to become a to the positive 5. I already have another a to the positive 5 down there that I'm not moving because it's already positive. B to the negative 3 is moving down. It's going to become b to the positive 3. I already have a b to the positive 5, so it's staying. But that means that the top is all gone. Yeah, you can't lose the top of your fraction, so make sure you put a 1 to hold it open. It's okay if the bottom all cancels off, but it's not okay for the top. The top will always be there. So if everything moves off the top, make sure you put a 1 there. So now we just need to simplify this a little bit. We're going to put these a's together under one base. When these bases multiply, the exponents add. So we have a to the 10. Same thing with the b's. When the bases multiply, the exponents add. So we have b to the 8. 1 over a to the 10th, b to the 8th. That's the answer. Okay, one more exponent question unless we have anybody bringing in stuff from online. Okay, this is probably the question 14. There's three exponent questions on this test, 12, 13, and 14. And they do get progressively more difficult. 12 is the easiest one, and 14 is the hardest one. Okay, in question 14, you're going to see the negative exponents, and you're going to see the exponent 0. So let's review. What does the exponent 0 mean? Any number to the 0 power equals not 0, 1. it equals 1, not itself and not 0. Any number to the 0 power is just plain old 1. Not x to the 1, not a to the 1. It's just plain old 1. So that's the first thing I notice when I look at this question, is this c to the 0 power. I can get rid of this. C to the 0 power equals what? 1. So I can replace this with a 1, can't I? Well, when you replace multiplication with 1, since this is all multiply, does it make any difference that you have the 1 there? A squared b to the negative 4 times 1 is still just a squared b to the negative 4. Now let me caution you. If in the odd instance you have a variable to the 0 power being added to another variable to the 0 power, you can't just x them out. Okay? You replace them with 1. And in this case, it does make a difference, doesn't it? Yeah. When it's multiplied, times 1 doesn't change anything. But when it's added, plus 1 does change something, doesn't it? So just be careful what the operation is when you just get rid of it. Since the operation here is multiply, times 1 isn't changing anything. Does everybody understand that? Yeah, okay. That was for free. Okay. All right, now we got to do something with this negative 3 out here, don't we? What do you guys think? What should we do with that negative 3 power? Yeah, that negative 3 is going to go on the a squared, and it's going to go on the b to the negative 4. It goes on both of those. So the shortcut when you have exponents raised to exponents is to multiply them. So that becomes a to the negative 6 power, because 2 times negative 3 is negative 6, and b to the positive 12, because a negative 4 times negative 3 makes positive 12. Almost done now, because at the end we want to get rid of those negative exponents. Right now, is it on the top or is it on the bottom? It's not a fraction at all. So is this the top or the bottom of the fraction? Yeah. Yeah, because it's a whole number, we write it over 1 and make it a fraction, and that tells us where that a negative 6 is going to go, isn't it? Where's it going to go? It's going to go down to the bottom. It's going to become b12 still on the top, a positive 6 on the bottom. Are we cool with that? All right, somebody in the room is asking me a question about raising to the 0 power. Are you saying if we have like a really complicated expression like this a squared b negative 4 c0 to the 0 power? What do you guys think this means? This whole base is being raised to this 0 power. Whenever any base is raised to the 0 power, it equals 1. This whole thing equals 1. Look for that 0 power. Look for that 0 power. If you have a whole, it doesn't matter what the expression is, a whole huge expression raised to the 0 power, it equals 1. Yeah, I see a question in your face. Yes. Yes, you're right. She's asking me about the 1 in the parentheses. Do you see the 1 right up here? It is. It's a squared b negative 4 times 1. That's exactly what it is. But when you multiply 1 times all of this, it's still a, when you multiply anything times 1, it doesn't change that value. So that's why I just dropped it off. You don't need the 1 because it's not changing the value of that expression when you multiply times 1. It's to see if you really know what this, the reason they put this c to the 0 power in here is to see if you know what that means. That the 0 exponent, any number to the 0 power, equals 1, and when it's multiplied inside of an expression, it doesn't have any value to multiply times 1. Okay. How about scientific notation? It's going to be a negative, a negative what? Okay, let's review some of the rules for scientific notation. All right, do you guys know any of the rules for scientific notation? You're going to rewrite these digits as a number between 1 and 10. That's the first rule. You have to take the digits and put the decimal in there so that it's between 1 and 10. Now, it won't work to put the decimal here because that will be smaller than 1, won't it? It only works to put the decimal here. It won't work to put the decimal here because that would be more than 10. There's only one correct place to put the decimal, and that's after the first non-zero digit. So these are going to become 1.95. We always have times 10. 10 is always the base. The exponent is always positive or negative, either or. We use positive exponents for really big numbers, negative exponents for really small numbers. This is a decimal number, right? It's a really small decimal number. You guys see that? Because just because it has a whole bunch of digits doesn't make it a big. This is a small, small, small decimal number. This is going to be a negative exponent. And how many places did you move that exponent to get it there? You moved it 7 places. So 1.95 times 10 to the negative 7. Any questions about that? No, we're good. Polynomials? Are we ready for polynomials? Yes? Yes? Okay. What's the important thing on this slide? What's the important thing? We're going to combine like terms. Absolutely. We're going to combine like terms, but before we do that, there's something else we have to take care of. We have the parentheses. Yeah, the really important thing they're telling me in the room is this negative sign right here. That negative sign is going to affect the parentheses all to the right of it. It's not going to affect anything over here, only here to the right. So we're going to drop the parentheses and we're going to combine like terms, but as we're dropping the parentheses, we're going to distribute this negative sign. Well, what happens when you distribute a negative sign? It changes all the signs inside the parentheses, doesn't it? So be careful because there's lots of negatives here. Again, you see all these negative signs, those little bells should be going off to be careful. It's a rule, it's a subtraction. And the rule for algebraic subtraction is that it really is just adding the opposite number. And to get the opposite, you distribute a negative sign. So that's the rule for algebraic addition. So this trinomial up here is not changing when I drop these parentheses. But this trinomial to the right of the negative sign is going to change all of its signs because I'm distributing this negative. This is negative 1 times 6x squared is negative 6x squared. Negative 1 times negative 8, negative 8x is positive 8x. Negative 1 times negative 5 is positive 5. Everybody follow all that with the changing signs thing? Okay. So what do we do next? Combine like terms. Good. Where are they? Makes what? X squared. And then what? Negative 8x and positive 8x. They cancel because they're opposites. Good. Positive 4, positive 5, makes positive 9. Now, just for practice sake, let's pretend like I have the same thing with a plus sign between them. What do you guys think about this? Does anything change? If you distribute a plus sign or a plus 1, does it change anything when you multiply times positive 1? If you distribute this as a positive 1, it won't change anything, will it? So this won't change the signs. This will just be 7x squared minus 8x plus 4, and this will all be the same, plus 6x squared minus 8x minus 5. So no changing when there's a plus sign between them. It will be a different answer because it was a different operation. That's what I was trying to show you. This is just for practice sake to show you the difference. This will come out to be a different answer, absolutely. Absolutely, because there's a difference between subtracting two things and adding two things, isn't there? That's why it comes out to be a different answer. Yes, absolutely. It's a totally different question, isn't it? Okay, so we're good with that? I really would like to go to some factoring because no? I can't. Can we go to some factoring? Okay. Okay, this one, the GCF, this, and then factor it. Okay, that's a good idea, because we can practice some multiplying and the factoring together, can't we? You guys do realize that the act of factoring is the opposite of multiplying? Did you realize that? When you're factoring a question, you're undoing distributive property. You're undoing FOIL or double distributive property. Factoring is the opposite of multiplication. So let's practice with this one. To simplify this expression, what are you going to do? You're going to distribute, which is multiplying, isn't it? Okay, so you see all the negatives again. Ding, 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 slow down. Negative times negative makes positive, so the first term is going to be positive. 7 times 4 is 28. X times x is x squared. X times x is x squared. Remember that when you multiply two of the same base, you add the exponent. This is the 1 squared. Okay. And then we're going to distribute here. Times positive makes negative. 7 times 7 is 49. Then you have just the 1x. All right, everybody's cool. We got the multiplication. Now let's factor it. So we're going to go backwards. And on your test, these two are not in the same question. I just want to make sure you guys aren't confused. These are not in the same question. But if the directions say factor completely, the directions will say factor completely. 28x squared minus 49x. This is not factored because there are common factors here. We're going to undo distributive property. Okay? When you undo distributive property, you first find the greatest common factor of these two terms. You have a 28 and a 49, so 7 is common. And x is here in this term, 1x here, so 1x. You guys remember this? You did this in class. When you factor out, once you find GCF, dividing both these terms by the GCF to figure out what's left in the parentheses. So 28 divided by 7 is 4. X squared divided by x gives you 1x, because remember you reduce them. You have a minus sign. 49 divided by 7 is 7, and the x's here cancel. Okay, but this didn't turn out to be the same as what we started with, did it? That's okay. This is still in factored form. The difference up here is that they purposely put this negative sign here and this negative sign here to see if you could multiply the negatives together. Okay, if you had this expression and you were asked to factor it, this is proper factored form here. But do you see how we undid distributive property? That's what factoring is. Yeah, there are 7 questions on this exam that involve factoring. 7. They're different concepts. So let's look at this one. This is another factoring GCF here. All right. It just says, yes, 18 was just multiply. Do you want to do 18? I was kind of talking about factoring, so let's move on with some factoring here. If you're going to factor completely, the first thing you look for is if there's any greatest common factor for all 3 of these terms. I have a 30, 14, and a 24. So they do have a common factor of 2. So, okay, that's part of my, I'm writing my GCF out here, the greatest common factor. I have y50, y55, and y15. What's common? They all have at least 15 y's. So with the variables, there kind of is a shortcut to figure out what's common. Does anybody know the shortcut? You choose the one that has the smallest exponent, right? Okay. Provided that each term has that variable, you can choose the one with the smallest exponent. So I have S8, S6, S6. So how many S's are common? 6. So this is the GCF. Now I'm going to divide each term by 2, 15, 6. Each term. I'm undoing distributive property here. So what is the first term going to turn out to be? 30 divided by 2. What's the shortcut for these y's with these exponents here? You're supposed to subtract. When base you subtract, that goes 50 minus 15 is 35 minus 2. Then I have plus 14 minus 2 is 7. 14 divided by 2, sorry. Y 55, and then Y 15. So when you subtract those, you get Y 40. What happens with these S's? Yeah, they're both the same on the top and the bottom. They'll cancel. So we have plus 24 divided by 2. Over here, the Y's cancel because they're both the same, and the S's cancel. So that would be it right there. That's factored form. Now, if you need to check your work, what should you do? Plug in what? Okay, I think you have the right idea. It's not necessarily plug in, but it's distribute. Do you see, if you distribute this now, you should get your original expression back, shouldn't you? Because you undid the distribute. So there's really no reason to miss these on the test because it's really easy to check your work. You know how to multiply. So you're unmultiplying when you factor, and you're going to multiply to check your work. What are you laughing about? They're asleep? Wake up online. Wake up. Wake up. All right. Question 20 is more factor. When I look at this expression, do I see any common factor? What's common? What factors do 25 and 64 have in common? Do they have any common factors? No, they don't have any common factors. And in this first term I have z squared, and in the second term I have x squared. So they're not even common. There are no common factors. So the kinds of factoring we can do, isn't there? Yes, question 19 is done. This was the final answer on question 19. So if there's no GCF, what other kinds of factoring can we do? Well, you could factor out 1, but that's not really going to help you here. Does anybody remember anything called difference of squares? That's right. Okay, that means that you have two terms, okay, two terms, that you have subtraction, right? And you have what? No addition, subtraction. You have squares. What does that mean, squares? They're perfect squares. They have square roots. There's one number that times itself equals that. Are these 25 and 64, are they perfect squares? Yeah, because 5 times 5 makes 25. Okay, and of course the z squared is z times z, and the x squared is x times. Okay, so this is the difference of squares, isn't it? Yes. Do you remember how to factor it? It factors to two binomials. There's really not a process here. It's just a matter of remembering what those binomials are. Okay. It's a plus and a minus. Absolutely. It's a plus and a minus. You take this first term, 5, what? Z. And those go right in, don't they? Then you take the square root of this term, and you get 8x, 8x. Now, the important thing is the signs, you guys. They are different signs. Okay? Because if you sign in, it doesn't make a difference of squares, and you should multiply to check your work, shouldn't you? How do you multiply these two binomials? It's called FOIL or double distributive, isn't it? I call it double distributive in my class, but it's also called FOIL. 5z times 5z is what? 25 that I can actually see. I tried to didn't really see it. There we go. We have 25z squared. And then what? What makes positive x z? And then what? Positive 8 times negative 8, negative 64, x times x, x squared. Do you guys see what's happening here? And you end up with 25 z minus the square. This is why I have two different signs. So those middle, if you have signs there, those middles will cancel. Right, you won't end up with the same thing. Yes? Yes, I can go back. Okay. You have, if you have a question that looks like this, or x squared, this is what you're asking me, right? And you're being asked to factor this, what do you think about it? You guys still see the perfect squares? Does everybody still see the perfect squares? Is this the difference of squares? Difference means what? This means subtract, okay? And since this is not the difference, the sum of squares. The sum of squares. I could go through a whole bunch of games with you guys to figure out what the factors are here. Turns out that this can't be factored. This is prime. There are no factors, no binomial factors that will allow you to multiply them back and lose the middle terms and still have a plus sign in the middle. This is prime, factorable, not factorable. Well, I can't write it because it's too close to the bottom, but you guys get the idea. This prime not difference, is it? It's a sum. So let's look at this one. Oh, this is factoring still. Are we good with this one, or do I need to review it? I need to review it. Okay, let's review it. No, there's no guessing allowed. No. Can you put IR and R together like on them? No, we cannot, because they are not like terms. They are not like terms. They don't have the same variables. If you're trying to simplify this expression, you are looking for like terms, and there are no like terms here. They're all different, aren't they? So this expression will not simplify any further than it already is. The directions are to factor it, tear it apart. Okay, basically factoring is the opposite of multiply. Okay, so we're going to break it apart. When you see something like this with 4 terms, first look for GCF. Sometimes there is a GCF, but there's no GCF here. There's nothing that's common across all 4 of those terms. The only other thing that we do with 4 terms is we split it in half, and we do what we call factoring by grouping. So now we're going to look for GCF just here in the front. What's common here in the front? The y. When you divide off that y, what's left? R plus k. Good. Bring this plus sign down. What's common in the back? B. And when you divide off that b, R plus k. Good. Now, this is the really tricky part that sometimes students have a hard time seeing this. Okay. You see the terms, it's just 2 terms. There's only one. They both have R plus m. So R plus k is common. So I'm going to factor out, I'm going to bring the R plus k to the front, and then really this is the process of dividing off R plus k. And you're left with what? You see you're left with y plus b. And you end up with these 2 binomials right here. Now, this is factored. See, we tore it apart, didn't we? We unmolded it, or unfit. Guys, you know the term? We unfit, basically. So if you need to check it, what are you going to do? I unfoiled it. You've never heard me say that before? I unfoiled it. If you need to check it, you should foil it. Or in my class, we call this double distribute, don't we? Because you're going to distribute this. So you guys check it. Make sure I did it right. You check my work. Right here. This is your answer right here. R plus k times y plus b. That's your answer. That's what that expression is when you factor it. It's R plus k times y plus b. Did you guys FOIL it to see if it works? R times y is ry. R times b is rb. K times y is ky. That's a k, not an r. K times b is kb. Is that the same thing? They're just in a different order. RY is YR, RB is BR, KY, I left out a plus sign, KB, it's the same thing, they're just in a different order, aren't they? So it works. This is the factored form though, right here. Oh, I don't want to do this one. I don't want any harder stuff. This one? A harder rational? No, I want the easy ones, not the hard ones. It's time for you to teach. Wait a minute, it's your turn. It's your turn. Wait. All right. This is after I do this one. You can finish up with some graphing probably. I'm not Elizabeth Washington. I'm Professor Barnett. Why? Are you disappointed? Okay, here we go. Here we go. We have a rational expression here. It says 8x squared minus 18x plus 9 over 4x squared. This is not in your book. This is from somebody online. It's similar to number 23. The directions for this question are simplify. Are that the right directions, Hector? Simplify. All right. This is just a big fraction, you guys, right? Yeah, fractions are your friends. Okay, it looks like a pretty complicated fraction, but that's all it is. This is a big fraction. When I ask you to simplify a fraction, what am I asking you to do? Okay, first of all, when you simplify a fraction, like 18 over 24, if I ask you to simplify this, what would you guys do? Tell me what you would do to simplify this fraction. You would look for the greatest common factor, which is what? 6. And what would you do with it? Okay, do you know what you're doing? You're just reducing, aren't you? You're identifying the common factors, and you're just canceling them off because they make 1, right? That's all you're doing. Identifying what factors are common on the top and the bottom and canceling them off because the same factors on the top and the bottom just make 1, don't they? So this is the same thing here. You're going to just first identify factors, and then you're going to cancel those factors, any factors that are common. Okay, so you have to factor the top and factor the bottom. And we haven't reviewed this factoring yet, so this is a good place to review it. This is a trinomial. These are both trinomials, aren't they? Trinomials will factor to 2 binomials because when you FOIL 2 binomials, you get a trinomial after like terms are combined. So when you factor this, there's a whole bunch of different ways to factor this, 3 or 4 different ways to factor this. So I'm going to do the way that I usually do in my class, you guys. Okay, so try and stay with me here. This is what I call a Columbian trinomial because the lead coefficient is something that's not 1. Okay, we didn't review the standard trinomials yet. When you have a trinomial with a lead coefficient like this, it's kind of complicated, but there's a few steps that we can do here. You take that 8. I'm going to rewrite this trinomial right down here so you guys can see the steps. 8x squared minus 18x plus 9. I'm going to factor it. I'm going to use the 8. I'm going to multiply times 8 on the front and the back. That gives me 64x squared minus 18x plus 72. Yeah, I've changed the expression. I'm going to change it back at the end. I'm going to take that 8 back off at the end, so don't stress out yet. Okay? And now I'm going to put some parentheses in because I'm making binomials. I'm unfoiling this. I'm unfoiling it. So you take the square root of this first term. We talked about square roots already. The square root of 64x squared is 8x. So I put those both right there. We did that before with difference of squares, right? This first sign comes down, and then I multiply the signs. Negative times positive makes negative for the second sign. All right? Now, if your teacher taught this a different way, that's okay. There's lots of different ways to do this. This is the way I teach it in my class. All right, when you have same signs, that means that the middle terms are adding because they're same signs. So I'm looking for factors of 72 that add to make 18 because that's what's in the middle. What are the factors of 72? That we might have to make a list, right? What are the factors of 72? Okay, 1 times 72, 2 times 36, 3 times what? 24? 4, does 4 go into 72? 4 times 18, 5 won't go into 72. 6 times 12, there we go, right there. 6 times 12. Do you guys see how organized I did that? I just 1, 2, 3, 4, 5. You just keep going down the line until you find them. So write the biggest one first. We have 12 and 6. Now, remember I used that 8 up at the top. Now I got to get that 8 back off. So I'm going to divide by any common factors I see here. This 8x minus 12, there's a common factor in these two terms. What do they have in common? What's the greatest common factor of 8x and 12? 4. 4. Yeah, and the greatest common factor of 8x and 6 is 2. They do happen to multiply to make that 8, so I'm dividing that 8 back off. You divide both of these by 4, you get 2x minus 3 times 4x minus 3. At the top, 2x minus 3 times 4x. Check an eraser thing. I don't. There it is. I just erase this. Sorry, guys. I'm getting really tired. All right. We're going to do the same thing with the bottom. So I'm going to kind of draw a line here so that we don't get the top and the bottom mixed up. I'm going to put 4x squared plus 9x minus 9 here. We're going to do the same thing. So do you guys remember the steps? You start with this 4. You multiply times 4 on the front and the back. 16x squared plus 9x minus 36. Then I make the parentheses. The square root of 16x squared is 4x. You guys got awful quiet. Are you still with me? The first sign comes down. Then you multiply the signs together. Positive times negative makes negative for the second sign. When they're different signs, the middle terms will subtract. When they're same signs, the middle adds, but when they're different, the middle subtracts. Those are just the rules for signed numbers, you guys. So you're looking for factors of, what are we looking for factors of? 36, that subtract to make 9. Let's see, factors of 36 that subtract to make 9. So let's write them over here. What are the factors of 36? 1 times 36. There you go. They subtract to make 9, don't they? 12 minus 3 is 9, so this must be a 12 and a 3. You always write the biggest one first because this has to be a positive 9. All right, now what's common? Let's get that 4 back off. What's common inside here? 4. What's common inside here? 1. See, 4 times 1 is 4. You divide, you get x plus 3 times 4x minus 3. Okay, now I'm writing that way up here again. X plus 3 times 4x minus 3. All right, once you have your fraction factored, you're going to cancel the factors that match. Do you see any factors that match? Yeah. You see, these will cancel off, and this will be your final answer here. That's a lot of work. There's only one of these on your test, but it is a lot of work. You see all that work? Do I feel like it? No, absolutely not. This is the same thing. This is the same thing. Okay, we're going to do this one more, or we might need to do one of these instead. Okay, I'm gonna pass you guys to Professor Alfaro. I'm gonna pass you to Professor Alfaro.
I'm kind of curious, how many of you guys saw that method before? We call it Colombian. Did you use Colombian in your class? How many have seen AC? Okay. Okay. How about online, Alberto? Have they seen AC or Colombian? Yes, which one? So they've all seen Colombian. Okay, so we can do this one in Colombian too. So this top one right here, if we're doing it with Colombian, we're going to take that number and multiply it. Professor Barnett was doing it to both of these, but I think in some of the online lectures we don't actually multiply the first one. That's okay, sometimes that's left off. Okay, but anyway, we'll put it on here. Okay. And then we're going to unfoil it, like she said. I like that. Take the square root over here. All right, and again, if you never multiply this first one right here in your class, that's okay, because notice it ended up staying 2x and 2x, right? All right, so we bring the first sign down, then what do we do? After we bring the first sign down, we multiply the two, right? A negative times a positive is a negative. The signs are the same, so that means that I'm looking for factors of 6 that add to 5. So what are some factors of 6? 6 and 1, 3 and 2. 3 and 2 are the ones I'm going to pick right here because they add to 5. You with me? They could add or subtract. It depends on these two signs right here. This one's negative and this one's negative, so in this case they're both going to add because they're both the same sign. Yeah, if the signs were different, then they would subtract. Okay, I usually put the biggest one first. Okay. And then we divide out the factors in common. What factors are in common here? I'll start with the one on the right. That one's easier, right? What's in common there? 2. What about here? 1. Yeah, when there's nothing in common, it's always 1. 1 always works. So we get 2x minus 3. And then this divides out to be x minus 2. I'm just going to put it up here. Are we good there so far? Okay. It is. I'm sorry. Thank you. Good catch. Because everybody would have just started looking at me weird and never said anything. Absolutely. It's x minus 1. Okay? We're good there. All right, let's do the bottom one. Is the bottom one a trinomial or is it a binomial? It's a binomial, right? So we can't use a Colombian here. It's not a trinomial. All right, so in the room they're saying that they're recognizing those perfect squares, right? X squared is a perfect square. 1 is a perfect square, but we need one more thing. They can't just be perfect squares. There needs to be something in the middle. It needs to be a difference. Yeah, perfect. A difference. So how do we factor difference to squares? You got it. X plus 1, x minus 1. And if we FOIL it out, we'll get back to x squared minus 1. So, all right, do you see any factors in common? X minus 1. So the final answer is 2x minus 3 over x plus 1 because the x minus 1's cancel. We're good? Questions online? Nothing? Okay. Do you guys want to do 24 or 25? 25? Okay. Let's do this one. So what do you notice about this type of trinomial? How would I factor something like that? It's a Colombian trinomial, right? We'll deal with the 0 later. Absolutely. Okay. So once again, take that 35 and multiply. Remember how I said it doesn't really matter with that first number? So I'm going to leave it out. I don't want to multiply 35 times 35. I'm just going to do it over at the end. All right, so negative 6 times 35. That turns out to be 210. Yeah? Okay? So then we go back to our parentheses, the 35x and the 35x. Remember, I didn't actually multiply these two. That's why the 35 stayed. Okay, let's do our signs. We bring down the plus sign, multiply the 2. A positive times a negative is a negative. So here we go back to that question. Are we looking for factors that add or factors that subtract? Factors that subtract because the signs are different, right? Okay, so we're looking for factors of 210 that'll subtract to 11. So what are some factors of 210? 1 and 210. That won't subtract to 11, right? 2 and 15. Okay. 2 and 15 actually don't work. Nope. Let's go back. 2 and 105. I'm glad we found the eraser. Okay. That won't work though. What else we got? 3. 3 is a factor of 210. 3 and 70. You know how I know? Yeah. If you add the digits of 210, you get 3. If whatever you get can be divided by 3, that means that the number 210 can be divided by 3. No, but you got to add them up. 2 plus 1 plus 0. If you get something divisible by 3, the number is divisible by 3. Okay, so 3 and 70, in either case, it doesn't work. Doesn't help me, right? What else we got? 5, 4, actually 4, 5 and 45? No, 4 and, does 4 go into 210? You guys help me out. What are you guys looking for? 4 and, you're saying 45? I don't think 45 will work. 5, let's see. 5 and not 45. 5 and 42. Okay, let's keep going. 7, 6 goes, yeah, 6 and 35. I know 6 because if it can be divided by 2 and by 3, then it can be divided by 6. Those are little tricks you learn along the way. 7 and 30. Good. We still haven't found factors to subtract to 11. I'll kind of give you guys a hint. I know. 21 and 10. And I know that because 210 can easily be broken up into 21 times 10 because it has a 0 at the end of it. Yes. Now this works. You can just keep going. You'll eventually get to the 10. Yeah. Okay. Ready to keep going? So finally, what's the last step here? I'm not done. I introduced a number that wasn't part of the problem. That was at 35, right? So I have to divide it out. So let's see, what can I divide out of the left side here? What's in common? To 35 and 21. 7. Good. What's in common to 35 and 10? 5. Awesome. So we get 5x plus 3 over here. And on the right side, we get 7x minus 2. Have we factored? We haven't factored? Which part? We factored. Now we have to solve. Good. We factored. We didn't factor because we've unraveled it. We've unwrapped it. We've unfoiled it, as Professor Barnett said. Now we have to solve, though. All right. Do we know how to solve for 0? Yeah? Say. Absolutely. Set this one equal to 0. Set that one equal to 0. Okay. Let's solve that. Can I erase my factors over here? So I need a little more room. I don't like this eraser. Yeah, it takes way too much to erase all this. Okay, so when we solve 5x plus 3 for 0, we're going to subtract 3 from both sides, right? So we get 5x equals negative 3, and then we divide both sides by 5. So we get that x equals negative 3/5. That's one of the answers. Let's do the other one. 7x minus 2 equal to 0. We're going to add 2 to both sides. So we get that 7x equals 2. Finally divide by 7. So we get that x equals 2 over 7. So we have two answers. X equals 2 over 7. X equals negative 3 over 5. It's okay to have two answers. Questions? Those are the two answers, yeah. Sometimes especially on your state test, you'll see them separated by commas. So it'll say something like this. Were they both negatives? Yeah. No, I don't think this one was. So you'll see something like this. Separated by commas. Questions about this one, or we're good? The other one, the one I skipped, is actually a lot easier. It's not a Colombian trinomial, just a regular trinomial. So you don't have to go through the whole Colombian method. Some square roots. How do we feel about square roots? These are square roots. Rational are these ones. Radicals, yes. Square roots are radicals. Square roots are radicals, yeah. So let's do it really quick. We tend to separate these in perfect squares and not perfect squares, right? So does 18 have any factors of perfect? Let's see, what are some factors of 18? 9, 9, and 2. And you may have done it with primary tree. That's okay. This is another way to do it. We do the perfect. Okay. Good. Okay. Let's do the x to the 7. How can I make that a perfect number of x's? Correct. So good. Somebody in the room said you have to have even numbers with the exponents. So we're going to separate it out into x to the 6 and x to the 1. W to the 4 is already even. So I'm going to put W to the 4 over here with the perfects. All the perfects we can square root pretty easily, right? The square root of 9 is 3. The square root of x to the 6, we divide that by 2, the exponent, and we get x cubed. Square root of W to the 4th, we divide the exponent by 2, and we get W squared. The imperfects, they're imperfect, they stay. They can't actually come out. And that's it. That's been simplified. It's the final answer. What's that? Oh, okay. How do you guys feel about this one? Do we need to do it? Is that a yes or a no? Yes? Okay. All right. It helps to look at, so 3 is the number on the outside, the square root of 2 is the number on the inside. Here I'm going to put a 1 in here so that I remember to multiply outside with outside, inside with inside. That's what we have to remember here. So we're going to distribute this 3 square root of 2. That's all one term. We're going to distribute that 3 square root of 2. It's just like we did before we started FOIL. We distributed. Okay? So, but outside with outside. So 3 times 1 is 3. Square root of 2 times square root of 10. Square root of 20. Good. Let's do the next term. 3 times a negative 5. Yes, right here. Right? And now I'm going to do square root of 2 times square root of 2. You with me? That's the square root of 4. But we should look and see if we can simplify. Remember how we did perfects and imperfects? Let's break up the square root of 20 into perfects and imperfects. Are there any factors of 20 that are perfects? What are some factors of 20? Yeah, and 4 is a perfect square, right? You want to finish that before we go on to the other one? Let's finish this one. What's the square root of 4? 2. Okay. And then just multiply this out. 3 times 2 is 6. So that's 3 square root of 20 converted to a 6 square root of 5 after I simplified it. Let me bring down the other one. Can I simplify that square root of 4? Yeah, the square root of 4 is 2. What's the operation between the 15 and the square root of 4? Multiplication, so I have to keep that in there. So 15 times 2 is 30. And that's it. That is our final answer. No questions on that one? There are two questions on radicals. One will be simplifying like number 26. One will be distributing like number 27. Sometimes it's double distributive. Okay. I want to do, let's see, the graphing, and then we'll go back to factoring. Yeah. Let's do graphing real quick, because graphing is always an issue. Do you guys remember how to do something like this? No? Well, this is in slope-intercept form, right? Which is y equals x plus b. So let's identify the m here. The m is a half, right? Because it's the number in front of the x. And the b is negative 4, which is what's added to the x. So m is a half, b is negative 4. What do they mean is the question though. Yes, the m is slope. The b equals the y-intercept. Almost. Okay, let's start by looking at the y-intercept, negative 4. Which one of these graphs has a y-intercept at negative 4? Let's see. The y-intercept on this first graph is negative 4, right? The y-intercept on this B graph is negative 4. The y-intercept on the C graph is negative 4. The y-intercept on the D graph is positive 7. So this one is wrong right here. That cannot be it. And this one on your final exam, you can do this one by process of elimination. Only one's going to work out. You guys with me so far? That's as much information as I can get out of the y-intercept. Now we're going to look at the slope to tell us which of the remaining ones it could be. So what kind of slope do you see, a positive or a negative? Positive. Do you guys know how to tell the difference in a graph when the slope is positive or negative? It goes left to right, it goes up, right? I like to think of a guy all the way at the left. Is this guy all the way at the left going uphill or downhill? Uphill. So this is a positive slope. How about this one? If I put a guy on the left here, see uphill or downhill? Up, so that's a positive slope. How about the guy here? Uphill or downhill? Down, so that's a negative slope, which we don't have here. So that one's wrong. We feeling a little better about this? Okay. By the way, just for fun, what's the slope on D? Positive or negative? Yeah, negative. So it would have been wrong anyway, because it's negative. All right, now it's between A and B. We just got to count. Slope is counted in rise over run, and you can count it from the y-intercept. So let's see, from the y-intercept here, the slope is 1/2. So I'm going to rise 1 up here. Scale is 2. It's going down by 2. And then we're going to go to the right 2. still on the line? Yeah, so that's probably it. I want to check the other line just to be sure that that's not the answer. If I go up 1 and to the right 2, notice how I'm off the line? So that means that that's not the answer. A is the answer. Okay. I have a couple of other factoring questions from online. You guys can stay and watch if you don't want to. That's okay. I can just record it for the web. It's up to you. They're good. Did you guys get it? And if you have any other questions, feel free to add. Why? We'll email an answer sheet out when we're done. So who's staying so that I know who I'm talking to? All right, good. All right, so we're going to factor this one, right? We always look for greatest common factor first. So do we see any greatest common factors here? Yes, we see an x or an a plus b is the greatest common factor. It's the greatest common factor because it's the factor of both. So I'm going to divide out by that a plus b, which is my greatest common factor. Okay, I put it up in the front. When I divide out by the a plus b, I get an x squared, and over here, I get a negative 25. So I've unraveled this some. I've factored it out some. A plus b times x squared minus 25. But what do we notice about the x squared minus 25? It's a special case. It's a difference of squares. So we're going to use the difference of squares there. Okay? So difference of squares for here. Remember how we do difference of squares? One's plus, one's minus. The two numbers that multiply to give me the perfect squared of x squared is x and x. The two numbers that multiply to give me 25, the perfect square are 5 and 5. And don't forget the a plus b, which was our GCF. So all three factors are our answer. A plus b, x plus 5, x minus 5. All right, sideways on this. Any questions online about this problem, Roberto? We're good here? Okay, I have another one. 4x cubed plus 12x squared minus 9x minus 27. There's a giveaway here that tells me how I should start to factor this. And the giveaway here is that I have 4 terms, right? Remember what to do with 4 terms? I do grouping. So I'm going to break this down the middle, do grouping. Let's look for a GCF on the left side. On the left side, my GCF is 4 and x squared. Perfect. So I'm going to factor it out. In other words, I think Professor Burnett was saying, in other words, you're going to divide it out from each one of these. So when we divide it out from 4x cubed, we get an x to the first power. When we divide it out from 12x squared, well, 12 divided by 4 is 3. X squared divided by x squared cancels. Let's go look at the right side. What's the GCF on the right side? 9. And yeah, whenever that first one is negative, we want to work with that negative. So it'll be negative 9. So I'm going to divide it out from both of these. Okay. Negative 9 divided by negative 9 is positive 1x. Negative 27 divided by negative 9 is positive 3. Do you see your greatest common factor here? Yeah, I see the x plus 3 is my greatest common factor. So when I divide that out, let's divide out the x plus 3. we get a 4x squared minus 9. Do you notice anything about the factored answer? Something special about it, right? Another difference of squares. So we're going to factor out that difference of squares again. And just to note that sometimes you have more than one way to factor things and you have to keep going. Alright, so the x plus 3 stays. The difference of squares of 4x minus 9 factors into 2x and 2x because those two multiply to 4x squared. 3 and 3 because they multiply to 9. And one's positive and one's negative. You can absolutely check this and get back to the same answer. I'm not good at making straight lines. Any more factor before I go on to, I have a slope one. Nothing? So the slope one? Okay. Yes? The question is how many word problems are going to be on the exam? I think that there's two. There's one translate to a word problem. So let me just go back really quick. If you get the worksheet, it was like number 11 or number 10. Oh, number 9 will be translate. Number 10 will be solve a word problem. And number 11 will be translate a proportion. So just like 9, 10, and 11 on the practice. Okay? Ready for the slope question? So the slope question is to find the slope of, and they give me 2 points. The 2 points they give me are half, -4, and the other point is 2/3, 6. You got to remember your slope formula. Or if at the very least you remember the slope is rise over run, you can probably get to the formula on your own. But the formula is y2 minus y1. So let's call this one y1 and this one y2. That'll find the difference in the y's, the rise, over x2 minus x1, which will find the difference in the x's, the run. So let's go ahead and subtract the y's. When I take y2, which is 6, minus y1, which is -4, I have double negatives. Keep that in mind. All over x2, which is 2/3, minus x1, which is a half. So many fractions. So let's go ahead and evaluate this. We're taking 6 minus a -4. That's really a 6 plus 4, right? So 6 plus 4 is 10. All over 2/3 minus a half. You got to think back to your fractions. How do we add two fractions? Well, they need a lowest common denominator, which in this case is 6. So how do we get the lowest common denominator? We're going to multiply by the factor that'll give me the 6 on the bottom. It's 2 on the left side, it's 3 on the right side. So we get 4, 6 minus 3, 6, which turns out to be 1, 6. So then I have to think of this complex fraction. That fraction bar just means division. So all that is 10 divided by 1, 6, which can be rewritten as a multiplication of a reciprocal, 10 times 6 over 1, which turns out to be 60. So the slope is 60. And all that means is if you think back to my little guy, let me do my line. Let's say the line looks like this. The little guy going up the hill has an elevation of 60. That means he's actually going up a really steep hill. So the line probably looks more like this, probably even steeper than that. That's all that means. The slope is 60. The slope is really steep. Anything else? Any questions here? Okay. Well, thanks everyone for coming.